Hello everyone. You're presently looking at Digi2O's HT128 distributed cable test system. These units are in general used in tests for open circuits, short circuits, and miswires in any cable harness fabricated. Firstly, let us discuss the HT128 technical specifications as you see it. You are presently looking at the HT128 unit, which weighs about 800 grams. The unit operates both on AC power source and battery power source. It has a rechargeable lithium-ion battery pack, which can operate the HT128 for about 10 hours between charges. The LCD screen is about 6 inches. We will look into various displays as we proceed in the demonstration. The unit has rubberized protection casing which helps in gripping the unit and also in some cases where rough handling is done in the factories. The HT128 comes with a 128-point adapter PCB which is fabricated into an adapter cable set. The 128 points also describes the number of test points available on the handheld unit. Now let's head right into the operational demonstration of HT128. Firstly, let us see some sample adapter cable and its possible connections. This adapter cable is fabricated such that the available 128 points are divided into 5 into 25 pin D sub connectors. So 5 into D sub connectors covers about 125 points, and we would have say about 3 spare cables which could actually be used for grounding and also for connecting open lines as it is required. So the D-sub connectors are of two types, female and male. Here we have connected 3 female 25 pin D-sub connectors and named it A, B, C, and 2 male 25 pin D-sub connectors named it D and E. Now let us see the options of connections. Since we have male and female connections here, we have B and we have D, which is a male connector and a female connector. So we could connect it in this way. And we have E and we have A, male and female, so we would want to connect it like this. So those are the options to connect the demo cable. Now looking at the HT128 itself, we would want to connect the adapter cable in the back side. This is just a cover. We could remove it in this manner, and we would see the spring-loaded 128 points available in the back. So the adapter cable will be mounted to the back in this manner. It gets locked. Now to power on the system, we press the power button here, and we could see the system coming to life. As we earlier discussed, we would look at the displays, various options available. We are presently looking at the main screen where you have options for fault test, repetitive test, probes, identify, in wire. So most of the options here will not be discussed during the demonstration because they have features which will take a longer time than the allocated demo time. Then we have three main buttons here: the settings, the home, and the previous button. The settings button in general will give us the options to set the tester in whichever manner the customer requires. And the home button will always take us back to the main screen. And the most important thing for the demonstration is the fault test. And that is the feature of HT128 that is mostly used by all operators. So let us look at the fault test. Once you use this test, we would at any point of time want to go back. We can use the back key to go back to the previous screen. Now to continue with the fault test will give us option to start, select the test ID, and view faults. All three are very important. The first thing that we would like to do is select test ID. These are the available tests loaded into the system. Presently, we would run the test in the center, which is called ST1 AEBD. AEBD is the connection that we actually performed right now. We connected the male, female, A to E and B to D. And so we will execute this test to show how the HT128 operates. Once we have selected the test, it would ask us about the adapter loom that is connected to the HT128. This is important when multiple of the HT128s are used. We would show that during multiple HT128 connectivity in master and slave configuration. So we have one adapter loom ADP01 and we are selecting it as OK. So we are ready to test. So there is a start button, we run the test, it shows us test running and we get the pass. So we press to continue, it goes back to the situation where we can repeat the test. This is the pass condition that you just saw. So to inject an error, we would like to show it by removing one of the connections here. So as per the test program, we are supposed to have say about 50 connections, 25 here and 25 between these two D sub connectors. So now let's run start. The test status shows running and you see the fail in red. So there is a button called press to continue. Now you go back to the test screen and you have an option to view faults. Out here in view faults, you actually get to see all the faults that are recorded during this test. So it is actually showing us that there was no connection between A1, E1, A2, E2, A3, E3, and henceforth to about 25, because each of the D sub is 25 pin connectors. So you would see that A25, no connection between A25 and E25. We could see all the previous screens. So this is an example of how the no connections are detected. We could further the test by actually interchanging the connections, where this would be called as the misfire. So instead of A and E being connected, we are connecting A and D, which is a mismatch or a miswire. And connecting B to E, which again is a miswire. Now we go back So the previous test was a fail condition, so it will always keep showing us the fail condition. We could redo the test just by clicking start. So the test is running, status is running. It is taking a longer time because it has to detect all the miswires. It has to firstly check for the right connections, then detect where all it has gone wrong, and then give us a fail. So the fail, press to continue, and if you go to view faults, it is actually showing the results where you can see that MW, the word MW means miswire. So it is showing that there is a miswire from A1 to D1, E1 to B1, A2 to D2. Similarly, 50 points will be shown as miswire because all the connections that were on the program has been miswired now. So A25 has gone to D25, E25 has gone to B25. In the actual proper scenario, A25 should have gone to E25 and B25 should have gone to D25. So all the miswires have been recorded and shown to us. Now we could go back and correct the connections and rerun the test to ensure that everything passes. So we go back. So we are connecting A to E now, which was the actual connection between points as per the test program, and we connect B to D. So all the connections are brought back as per the test requirements or as per the cable harness requirement. Now we run the test again. So the test status shows running and we get a pass condition because all the connections have come back to its original form. So this is how the HT128s are in general used to test harnesses for open circuits, short circuits, and miswires. We also have the second HT128 here, which can be used in a master-slave configuration. This is especially required when large circuits are being tested, large circuits more than 128 points, or circuits which needs the tester to be spread across the product. For example, multiple sections of the aircraft being tested, or multiple sections of a truck or a bus being tested. So one of the HT128 would be probably in the front, and one of the HT128s would probably be located somewhere in the rear section of the bus. And both the HT128s will interact with each other over RF communication. It has a range of say about 50 meters. So each of the HT128s can be separated by about 50 meters, which is more than sufficient to test a large aircraft. So by using multiple HT128 units, we could actually have multiple of the 128 test points, and 8 such HT128s can be configured in a network. That will accumulate to say about 1024 points being tested in one shot. Just to demonstrate how the master and remote configuration happens, let's go back and connect both the HT128s. We now power on the second HT128. Let's look at the connections required. So the home screen of both these HT128s presently look the same. That is because as of now it has not been configured in the master slave configuration. Now we connect. We will use the same set of connections as we did for the single unit. So A will be connected to E and B will be connected to D of the second unit. So I'm looking at so A of HT128.1 is being connected to E of HT128.2, and then the B of HT128.1 will be connected to D of HT128.2. At this point, there is interconnection in the adapter looms of HT128.1 and HT128.2. So let's now start testing the cable. The unit that we are working on will always become the master, because we always select the test ID and the adapter IDs from this handle unit that we are working on, and the other will automatically turn into a remote terminal, which you can see as we configure the system. We are going into the fault test icon. We are going to select test ID. We have a program called ST2AEBD. Again, here AEBD is the 25-pin connector of A is connected to 25-pin D sub connector E of the second unit. Similarly, B of the first unit is connected to D of the second unit. So the moment you select the test ID, now you would see two adapter looms being shown in the screen. That is because we are presently working with two HT128 units, and both of them have adapter cables, and one of it is named as adapter cable 1 and the second is named as adapter cable 2. So we will have to assign the test adapter with the appropriate tester. So we would go into assign. The test adapter 1 is connected to 2, and I would say test adapter 1 is connected to the second one. So now we have connected, and you would see that the second system is gone into remote display mode. It automatically goes into a remote display mode. That means it has become the slave in this particular test. So the moment you come back, you could say disconnect. I would just want to show it to you again. So I'm using the first HT128 unit. I'm going into the test ID selection. I'm selecting the test ID. I'm assigning the adapters. Adapter 1 is assigned. As soon as I select the second adapter, the unit here becomes remote display. So this becomes the remote terminal. So the main control is always in the HT128 unit that was used to configure the test. So the program will have to be run in the master system. So I've already configured the system here. So I would start the test. The test status shows running. And now that we have made connections between A, E and BD, we get a pass which indicates that the connections are all fine. Similar to the earlier error injection, we could probably just remove one of the connections here. I'm just removing one of the connections. I could go back, run the test again, and now it should actually show me a fault condition because 25 pins have been removed. So no connection between 25 pins. So it shows me a fail. When I go into view faults, it actually shows me no connections between A1 and E1, A2 and E2, A3 and E3. So those are the connections that were made to have a pass condition, And now that we have removed, all these have been showing us NC. NC means no connection between those points. So A25 is not connected to E25 is what it is showing. So this is how HT128 units are used to test various harnesses. So when multiple HT units are used, the unit which is being used is always the master, as I described, and the other terminals, other HT128s will automatically turn remote or the slave terminals as soon as the configurations are done on the master. So hope the demo and illustrations helped you to understand the features and capabilities of HT128 unit. I would request all of you to get in touch with us for a live demonstration and better understanding of the units. Please feel free to call us for further technical discussions. And thank you very much. Thank you to have viewed the demo. Thank you.